Taxi Ola, it's your boy Sam. Welcome to my SPM YouTube channel. Today we'll be mastering the geometry game with how to ace Euclidean Geometry questions part 3. You know I always want us to piece together the puzzle of Euclidean Geometry. Again and again, let's ace it to the hilt. Here we have question 9 of Euclidean Geometry with sub-questions that contain 5, 3 and 2 marks, but we don't care until we finish determining unknown angles on our diagram. Let us read the statement first. In the diagram, triangle LNR is drawn with points L and R on the circumference of the circle. NR cuts the circle at M. K is the point on LR with K and the bisector of angle L and R. KN cuts the chord LM at O. LK is equals to LO. Angle LOK is equals to 65 degrees and angle KNM is equals to 25 degrees. On our diagram, we are told that Kn is the bisector of angle L and R. Okay, to bisect means to divide something into two equal parts. Kn divides angle L and R into two equal parts. So, angle N1 is also equals to 25 degrees. Kn divided L and R into two equal parts. Angle O2 is on the straight line with angle LOK that has the value of 65 degrees. So angle O2 is equal to 180 degrees minus 65 degrees, reason angles on the straight line. Angle O2 is equal to 115 degrees. Angle O3 is vertical opposite angle LOK that has the value of 65 degrees. So angle O3 is equal to 65 degrees, reason vertical opposite angles. On triangle LKO, we are given that LK is equal to LO. So angle K1 is equal to angle LOK. Reason angles up is equal to sides. K1 is equal to 65 degrees. Okay, there's no space in this triangle, so let me put it here. Let me put it here and show that angle K1 is equal to 65 degrees. 65 plus 65 is 130. So angle L2 is equal to 50 degrees. The reason is sum of angles in a triangle. Let me write it here. L2 is equal to 50 degrees. In triangle O and M, M1 is equal to 180 degrees minus 65 degrees minus 25 degrees. The reason is sum of angles in a triangle. M1 is equal to 90 degrees. Another thing about angle M1 is that it is the exterior angle of triangle LRM. And what we know about exterior angle of a triangle is that it's equals to two opposite interior angles of a triangle. So angle M1 is equals to angle L2 plus angle R. Reason exterior angle of a triangle. We have values of angle M1 and angle L2, so let's substitute them. 90 degrees is equals to 50 degrees plus angle R. Angle R is equals to 40 degrees. Let's find the value of angle L1 that is inside triangle LON. Angle L1 is equals to 180 degrees minus 150 minus 25 degrees. Angle L1 is equals to 40 degrees. I think angles that we determined on our diagram will enable us to solve questions. So let's solve questions. 9.1. Prove that Ln is a diameter of a circle passing through L, M, and N. The very first thing we'll need to draw a circle that passes through L, M, and N. So let's draw it. Yeah, there it is. It's not perfect, but you can see that it's a circle. Back to the question, we must prove that Ln is a diameter. So for us to be able to solve this question, we must ask ourselves this question. What does diameter do on a circle? We all know that diameter subtends 90 degrees angle on a circle's circumference. So if we prove that angle M1 is equal to 90 degrees, then Ln is a diameter. We already determined angle M1 as 90 degrees in our diagram. You can see that it is important to determine unknown angles before us to solve questions. So let's show how we found angle M1 as 90 degrees step by step. Okay, we said that angle O3 is equals to angle LOK is equals to 65 degrees, as in vertical opposite angles. Then we determined angle M1. Angle M1 is equals to 180 degrees minus 65 degrees minus 25 degrees. Reason sum of angles in a triangle ONM. Therefore, angle M1 is equals to 90 degrees. We are done with showing that angle M1 is equals to 90 degrees. So right now we can conclude that Ln is the diameter to the circle LMN, reason converse of angle on a semicircle. We can move to the next question. 9.2. Determine the size of angle L. We are done with determining the size of angle L on our diagram as 90 degrees. But then we need to show how we found that angle L1 is 40 degrees and angle L2 is 50 degrees, step by step. We said K1 is equals to LOK is equals to 65 degrees, reason angles op is equals to sides. After that, we determine the size of angle L2. L2 is equals to 180 degrees minus 65 degrees minus 65 degrees. Reason sum of angles in triangle LKO. Therefore, angle L2 is equals to 50 degrees. Then let's show how we found that angle L1 is equals to 40 degrees. We started by saying angle N1 is equals to angle KNM is equals to 25 degrees. Reason KN bisects angle N. Angle O2 is equals to 180 degrees minus 65 degrees. Reason angles on a straight line. Angle O2 is equals to 115 degrees. Angle L1 is equals to 180 degrees minus 115 degrees minus 25 degrees. Reason sum of angles in triangle LON. Therefore, angle L1 is equals to 40 degrees. Since angle L is equals to angle L1 plus angle L2, angle L is equals to 40 degrees plus 50 degrees, angle L is equals to 90 degrees. We are done with question 9.2. We can move to the next question. 9.3. Show that Ln is a tangent to the circle LMR. The very first thing we must do, we must draw a circle that passes through points L, M, and R. Let's draw it. Okay, we are done with drawing the circle. For us to be able to solve this question, we must know what is the converse of tangent theorem. Let me explain it to you using this diagram. If you were given that UP is the tangent on this diagram, tangent theorem states that angle EUP that is between the tangent and the chord will be equals to angle A that is in the alternate segment. But then what is the converse of that? The converse is if angle A is equals to angle EUP, UP is the tangent. The converse is like the reverse. Back to question 9.3. We must prove that Ln is a tangent to the circle LMR. Okay, how are we going to do that? If we prove that angle L1 is equals to angle R, then Ln is a tangent. In our diagram, angle L1 is equals to 40 degrees and angle R is equals to 40 degrees. They are equal, but we need to show how we found that. In question 9.2, we show that angle L1 is equals to 40 degrees. So on this question, we only need to show how we found that angle R is equals to 40 degrees. Okay, we said angle M1 is equals to angle L2 plus angle R. Reason exterior angle of triangle LRM. 90 degrees is equals to 50 degrees plus angle R. Angle R is equals to 40 degrees. Angle L1 is equals to angle R. Reason both they are equal to 40 degrees. Therefore, Ln is a tangent to the circle LMR. Reason converse of tangent theorem. We are done with question 9.3. Let's move to question 9.4. 9.4. Is LR a diameter to circle LMR? Motivate your answer for 2 marks. What does diameter do? Diameter subtends 90 degrees angle at the circle circumference. For us to know whether LR is a diameter or no, we will need to calculate angle M2. If angle M2 is equals to 90 degrees, LR will be the diameter. If it's not equals to 90 degrees, LR is not a diameter. Let's calculate angle M2. Angle M2 is equals to 180 degrees minus 90 degrees. As in angles on a straight line, angle M2 is equals to 90 degrees. Since angle M2 is equals to 90 degrees, LR is a diameter to the circle LMR. As in converse of angle on a semicircle. That's all for today's video on how to ace Euclidean Geometry questions part 3. If you found this video helpful, please give it a thumbs up and subscribe on my YouTube channel for more math lessons. Your support means a lot to me and I'd like to have you join our community of learners.